So the first one we're going to look at is the parameter c. This reads c is greater than 0, but as you've heard me many times say, that's simply just a way to write that c is positive. So I chose my value of c to be a 3, so for the cubic function I would plug in x minus 3, because remember up here the formula says x minus c. That means if I plug in a positive 3, I'm going to still read x minus 3. That x minus 3 is going to cause my graph to shift to the right. Since it's shifting to the right, I should take my current x values and add 3 to them. Since I'm not doing anything to d, or I'm not stretching it in any way, my y values do not change. So I would take each one of those x values that I plotted right up here, and to see the transformation I would just add 3 to x. So my x value is -1. -1 plus 3 I believe is a 2. My y value stays the same. 0 plus 3 is 3. My y value stays the same. 1 plus 3 is 4. My y value stays the same. My x value is 2. 2 plus 3 is 5, but my y value stays the same. That is an example of a positive c value. So the next example is it reads c is less than 0, but we know that we're talking about, in that particular case, we're talking about c values that are negative. So if I let c be -3 in this case, we know that it's going to translate it to the left 3 units. So if I take this graph up here and I shift it to the left 3 units, I'm going to move it to the left, then the x values, I'm going to take 3 units away from each x value. Again, I did all of on this equation right here. The only change that I'm applying is this value of c. So to find out where my new points are, I'm simply going to take 3 away from each one of the x values. So -1 minus 3, I believe, is -4. The y value stays the same. 0 minus 3 is -3. The y value stays the same. 1 minus 3 is -2. The y value stays the same. And 2 minus 3 is -1. The y value stays the same. And this is where, if y'all hear me do some little calculation mistake, please just catch it and fix it in your notes. I don't think I had any right there, but when I'm doing mental math, it's very easy for me to mess up. So if you find a mistake, if you hear me do a mistake, just fix it in your notes, please. Okay, the next parameter we're going to look at is d. D is also a translation. Here's where it says translation. Translations are caused by numbers that are added or subtracted to the equation. Horizontal ones are, remember, are out or inside. Vertical ones are outside. So we're looking at d. This first one says d is greater than 0. That's how it reads, but we know that if it reads d is greater than 0, we're really talking about a positive d value. So I picked 2 to be my d value. I stuck it on the outside. Here's the cubic function. We're not cubing the 2. That's why I'm calling it outside. I did put it in front. Why? Because you can. This equation right here is the exact same as this one. We do normally put d in the back, but you should be able to recognize it if it's written in the front. How can you recognize it? Because it's being added to that. Anytime you add or subtract to your function, it is a d value, a vertical translation. And vertical translations change your y values. Vertical changes y. Vertical means up and down, so we're changing our y values by the exact same amount of our d. So we're going to take each one of these y values of the parent function, these 3 points right here, and we're going to add 2 to them. So -1 plus 2. I believe that's a positive 1. 0 plus 2 is 2. 1 plus 2 is 3. And 8 plus 2 is 10. If D is less than 0, that means D is negative. So I chose my D value to be -2. When we type it into the equation or plug it into the equation, it's going to read something like this: x cubed minus 2. I could put the -2 out in front. Why didn't I put the minus between the two? Because if I put the minus between the two, now the x cubed is negative and not the 2. So be sure the minus sign goes with the appropriate value. The 2 is what's negative. The x cubed right here is positive. So we are going to take 2 values away. It is shifting it down 2, so that's why we're taking 2 y values away from each one of our y values. And here we have -1 minus 2. I believe that gives me -3. 0 minus 2, 1 minus 2, and 8 minus 2. So that's where our points on our parent function would be transformed to these new points. Notice each one of them has been shifted down 2. So if we are looking at A has 3 conditions listed right here. I actually work these two with the absolute value around it, because I like to say ignore the sign, but is A a number that's bigger than 1? So over here, in other words, it doesn't matter if this was a +2 or a -2, it would still represent a stretch. If it was a -2, we would first indicate about the reflection over the x-axis, but then we would also talk about it being a stretch, because 2 is a number that's bigger than 1. The negative is only used to determine if it has a reflection or not. So if I have a value of 2, 2 is a number that's bigger than 1, so we have a stretch by a factor of 2. And it's vertical. So vertical is changing the y values. Anytime it's vertical, it's going to change the y. So, and notice that the 2, notice how we have it written up here. It's A times, that's the operation right there, is multiply. And so if you multiply, then you're going to change the y value by multiplying. So this y value right here gets multiplied by 2. So you take each one of the points that we have, the x values stay the same, and we just double the y values. So -1 times 2 becomes -2. 0 times 2 stays 0. 1 times 2 becomes 2, and 8 times 2 becomes 16. So that's how an A value changes the ordered pairs. And a vertical stretch means it got taller, it moved further away from the x-axis. If A is a fraction, or if I wrote the absolute value of A in there, then I would be saying ignore the sign of A. But if A is a fraction, then you're going to have a compression. That means it's getting shorter. It's going to move closer to the x-axis. Each point is going to move closer to the x-axis. You take the value of A and you multiply it times your y. Why? Because it's a vertical change. So take each y value and multiply it times 1/2. So we have -1 times 1/2, that's -1/2, and of course you can write 0.5 there if you'd rather do that. 0 times 1/2 is 0, 1 times 1/2 is 1/2, and 8 times 1/2 is 4. So that's why I said they got closer to the x-axis. They're shorter. They're not as high. They're not as far up or down as they were. So that's why it's called a compression, or the word shrink. It could be a vertical shrink. Okay, so if A is negative, and I don't care whether it's a -2 or a -1/2, if A is negative, we're going to still multiply by A, but we're going to change the sign. So if we just end up with a -1 in this case, if all we see is a negative, then all that's going to happen is we're going to change the sign. If it was a -2, we would multiply by -2. The negative's going to change the sign, the 2 will stretch it. If it was a -1/2, we would multiply by -1/2 right here. The negative would change the sign, and the 1/2 would shrink it. So the negative, we deal with that the same way we do everything else. So this becomes a +1. This stays 0. this becomes a -1, and this becomes a -8. And we have a reflection over the x-axis.